Hello guys, let's continue developing our garbage collection. This session it's just for testing what we developed until now. So I created a simple program that's called the native function clock, and it prints that. So I will run my end interpreter on the sample and we will see. So as you see, we have a segment fault, and this session will be just for debugging the bugs inside the garbage collector and fix them. So as you see, we have the begin and end of garbage collector. We have here collected 0 at the end, so here we have an allocation, and then the next GC we have a free of that address, and so on. And finally we have some segment fault, so we will use a GNU debugger to see how to fix that problem. So I will use the GNU debugger with some arguments and the interpreter end with the script sample.end. And before making a breakpoint, I want to go to vm.c, and I suspicious this part because the bug, I suspicious that it happened in this part, so at the line 33. So what I will do is to make a breakpoint in that debugger. So I will do break on the vm.c and on the line 33. So I will run that, and as you see, the init VM function will start, and I will go instruction by instruction and see what will happen. Okay, we have the initializing of gray count to 0 and capacity, and the gray stack to null. Always everything is good until now. We have initializing of byte allocated 0 at the initial. Okay, we have the initialization of table string and table global, and here we have the allocation of the init string that we used in OOP as a constructor name of the class. So, and then this will happen. As you see, we have a begin and end for the garbage collector because we have an allocation. Remember guys, we have the mode that we execute the collected garbage is on the mode stress. So at each allocation we have a start of the collected garbage, and then we have another call of the garbage, and also we have an allocation. So this allocation is the allocation of the init string, and then it is freed. So that's is not what I want. I don't want the init string be freed. So let's go to object.c and see the function copy string, what it happened. So we have here we have an allocation of the size of the string. So in the allocation we will call the reallocate function, and the garbage collector will start and it will end because we have nothing to collect. After that we have a allocation of, we return an object string, and in allocate string we allocate the object string, and if we call that, which means that is called, so this will run the garbage collector, and also it run this statement. So as you see, we have the garbage collector, and also we have the allocation of that string. Okay, and what is happening here? Then I will go to table set, and I will add that string to table set. So let's go to table.c and table set. We'll search to table set. So as you see, the table set here, first of all, the table entry is with capacity 0, so we need to allocate some extra memory, and this grow capacity will run. And when the grow capacity run, which means that the function we allocate will run also, and the mark root function will run, and everything will run. And here after this the garbage collector, it will run in the table set, because as we see of this instruction grow capacity, inside the grow capacity we call the reallocate, and the reallocate, it has the garbage collection. So which means that the string that we create is not on the stack, and also is not on the table of globals, so it is not stored anywhere. So which means it's not it seems as not a root object. So what we need to do is to push that string on the as an object var on the stack, and then I will pop it here. Why I do that? Because it might happen the garbage collection inside table set, and that object is newly created, and I need to push it to the stack, so the garbage collector will mark it, and in the phase of sweep we will not remove that, so this will not happen for the next time. So first of all, we fix that problem here, and let's close all these. So let's stop the garbage collector, let's stop the debugger. Okay, and I will rebuild the project. Okay, we don't have push and pop, so I will go to vm.h, and I will add these two functions. The first one is push, and I will push some value, and the second one, which will return a value, and the function is called pop. So let's go to vm.c, and let's remove that static from here, and also that static from here. Okay, that's fine. So let's rebuild the project. Okay, everything is good. So let's run our debugger. I will make a breakpoint on the vm.c on the line 33. So we'll run that, and I will do the next instruction, and the next instruction, and so on. So here the copy string, so the garbage collector will start here. As you see, the init string is not removed, is not freed, and as you see here we have blackened init string. So the init string is now treated as a reachable object. So let's continue and see if we have any other bugs. So as you see here, so let's continue the win. Next. So here we have a segment fault also. So let's see what happened in here. So after we run the file on the argument scripts.end, so we have the init string is happening, is blackened. So at the next GC it will not be removed. So as you see, we've also allocated some other object. Okay, and what's happening? So let's see. Okay, which one is freed is the okay, as you see here, we have freed the script, and that's why we have a segment fault, because we have freed the script, and the script is we need that script on the stack so we can run that function. So to solve that, I will go to vm.c, and on the function so let's go here. So here we have the compile return that function. So what I need to do is to push that function on the stack, object var function, and when we create the closure, because of we stress the collect garbage, so in this creation of closure will trigger the garbage collector from start, and this object function will not be blackened. So I did push it to stack to be blackened, so because I need it on the stack. And then if I create that, if I push that function to the stack, I will pop it from it, because the garbage collection might be triggered in this instruction. So we'll fix that problem for now. So let's rebuild the project from the start, and let's see if we run the debugger another time, break on the vm.c 33 at line 33, and I will run. So next instruction, next. So okay, next. Okay, so we have a runtime error that says can only call functions and classes. So this is not treated as a native function. So as you see, as you see here, we have an allocation, and then I have freed that allocation. So that will happen, I guess. So I guess in this function vm.c. So let's go to define native. As you see here, we have a copy string. So it might be that the issue is here, because when I call the copy string, it will trigger also the garbage collection, and also when I call that, it will trigger the garbage collection, so it will remove that object string, because it will not be blackened, it will not be reachable. Also, as this native object also, when we create a native function, will trigger a garbage collector, so also that it will not blacken the native function, so the garbage collector will free that. So I guess that's the problem. So let's remember it's the line 18. I will run the debugger from the start, and I will choose another line 18. So I will run. So okay, we have the normal things, we allocate init, and here we are on the function define native. So next, as you see, the init is always blackened. The init is always blackened. Here we've allocated the object string, and here it will be freed, as you see. So that might be the issue. So I will go here, and what I will do is to push object val key, and also I will push object val object1 native, and then if we add that on the table, we will pop them both. So I guess that will fix the problem. Yes, that will fix the problem. So let's rebuild the project from the start. So everything is good. So I will net int, and I will run our interpreter from that script. So as you see, it print the clock, the time in seconds. So as you see, when the garbage collection is finished, it freed every object. It freed all objects. So let's do one more thing. I guess I will disable the log messages of garbage collection, also as trace of the stack, also as bytecode. So as you see, it print that. That's good. So I will make another example, and this time I will work with strings. So I will print int. So let's see what will happen. So also we have a segment fault. So to understand the problem, we need to understand how the compiler works for strings. So as you see, we have a copy string that trigger the garbage collection, and also we have that make constant, and the make constant some value. The make constant, it uses the write constant function, and in that write function constant we have some macros that grow the array of the constant, and if the macros that grow the array also it trigger the garbage collection. So what I need to do is to go to vm chunk.c, and as you see here we write a value on the table of constant, but at the first time this table of constant it has no capacity, so it will trigger the grow array macros. This grow array macros will trigger the garbage collection. So here I will push that value, so I can't lose it. I will push the value this, and I will remove that, and I will pop it from the stack. Why I did that? So the garbage collection, when it mark object, it will consider that because it is on the stack, and then I will pop that from the stack, and then I will return chunk constants, chunk constant count -1. I guess that's it. So as I said, I just push that value in the stack and I will pop it because it might the garbage collector triggered in here. So when the mark process goes, it should mark that because it exists on the stack, and then when I finish that I will pop it from the stack and I will return the count -1. So that's it. Let's rebuild the project. Okay, chunk.c, I will add include vm.h, and that's it. Okay, that's good. So let's rerun, and as you see, it print sample size. So we fixed that problem. So let's do another example. I will add two strings and 2 times. So everything is good. So let's enable stack and the debug log for garbage collector, and let's rebuild the project. So as you see, we have marking objects and blacken objects and so on, and we allocate objects and also we free objects at the end. So we have a working garbage collector. Now we have a automatic garbage collector for our end language. It's a garbage collected language. So see you guys. So before that, I will go to memory.c, and as you see guys, this garbage collector that we built, it rely on this function collect garbage. But remember guys, we run this garbage collector at each time we have reallocate. We stress the garbage collector. I did that just for the purpose to find bugs in the garbage collector, because it is hard to find issues in a garbage collector. So see you guys in another session.